Hey guys, 6.2 quadratic models. Okay, so let's start by reviewing what you guys did in secondary one. So in secondary one, you did linear equations, and I hope you ran into problems that kind of look like this. So write the equation of each line using the given information. So for A, it says a line with a slope of 2 through a point -3, comma, -7. All right. So if you can remember, pencil. Linear equation is y equals mx plus b. All right, where m is the slope and b is the y-intercept. Okay, so looking at A, it says we have a line with a slope of 2. So we have our equation y equals 2x plus b. Okay, we don't know what b is, but they give us a point, an ordered pair. We know an x, given an x, it gives us, we have a y. So we can plug this point into our equation. So we get -7 is our y, equals 2x, and then, our x is our -3 plus b. And now the only thing we have left is b, and we can solve for b. So simplify a little bit, 7 equals -6 plus b, and then we're going to add 6 to both sides, and we end up getting b, well, maybe I'll keep it on one side. That gives us -1 equals b, or oftentimes we'll write it as b equals -1. Okay, so now that we have b, I guess we're not we're not finished, because they want us to write the equation. Let me take that box away. Okay, b equals -1. So now we just plug that into our equation to give us y equals 2x minus 1. That is our equation, and it's our solution. Okay? All right, so we'll be kind of doing this same thing, but using quadratic equations rather than linear equations. Okay? B, a line with y-intercept. So y-intercept, that tells us that our b value is for our y-intercept, b equals 4, and then gives us a point. So we kind of do the same thing. We'll say y equals mx and then plus 4. Okay, it's our y value for our y-intercept. And then we have a point, and we're going to plug that point in. So we get 3 equals m, and our x is our 5, plus 4. And then all we have left is m. So let's solve for m. We'll subtract 4 from both sides. That gives us -1 equals m5, or 5m. And then we're going to divide both sides by 5. We'll end up giving us m equals -1/5. Okay, and then we take that and plug that back into our equation. So y equals -1/5 x plus 4. Okay, so hopefully that's not too bad. If you don't remember how to do this, or if this isn't enough of a review, I would suggest coming and talk to me about that. Hopefully with these examples that will help. Okay. The equations you wrote above are linear models. Today we will be focusing on quadratic models. For each form, identify what information is given by each feature in the equation. So what we're saying is if we have it in standard form, what does, like for example, this one, A and C, what do they tell us about our equation? Well, A will always tells us the growth pattern, okay, and the growth pattern is in every form. Okay, and then C, if you recall, C helps us with our y-intercept. Specifically, 0, C is our y-intercept. Okay, P and Q, that gives us our x-intercepts, specifically P, 0 and Q, 0. All right, and vertex form gives us the vertex. Okay, H, K is the vertex. So we'll want to look at that when we are doing these problems, because we want to see, okay, let's just start with an example. It says, knowing this, try the following problems. Write an example or an equation that models the given information. So a quadratic with, a quadratic with x-intercepts of 2, 0 and -2, 0 goes through the point 0, 4. All right. So if we're given x-intercepts, well, for sure we want to use intercept form, okay, because that gives us our P and Q. So we'll write this equation as much as we can. We don't know what A is yet. X minus P and X minus Q. Well, P and Q are 2 and -2, so we'll plug in 2, and -2 will give us a +2. And what we're missing is A. They don't give us what A is, but they do give us a point. So we do the exact same thing we did with linear equations, is if we're given a point, we can plug those in. So here we have this 0, we can plug that in for our x's, and we can take this 4 and plug that in for our y. So that ends up giving us 4 equals A, and then we'll do 0 minus 2 times 0 plus 2, simplify, 4 equals A times -2 times +2. That gives us 4 equals A times -4. Okay, and we want to get A all by itself, so we divide both sides by -4, and that ends up giving us A equals -1. So now we have what A is. We are just going to plug that in to our equation right here. So that gives us y equals -1. You don't need to keep the 1 if you don't want. You can write it just like this. And that is our equation. Okay? So let's go over a few more of these examples. Equation with x-intercepts. So we're going to do basically the exact same thing. We just have different numbers. So we'll write this as y equals A x minus and x minus. Okay. P is -2 and Q is 4. You can switch those. Those don't matter. It doesn't matter which one they go with. Okay. Then you plug those in. That ends up giving us a negative to give us a +2 and -4. Okay, so all we need to do is plug our equation in, our ordered pair, our point, into our equation. That gives us 4 equals, we still have the A, and then we have 2 plus 2, and then 2 minus 4, gives us 4 equals A times 4 times negative 2. 4 equals A times negative 8. And then divide both sides by 8. A negative 8. That cancels. And that leaves us with A equals negative 1/2. And then, since we have A, that's the only thing that we were missing, is we will take it this way and plug it in. And that gives us Y equals negative 1/2 X plus 2 and X minus 4. Okay? All right. Now we're looking at something a little different for these problems. We have a quadratic with a vertex. So they gave us a vertex. So which form do you think we're going to use? Well, we're going to use the vertex form. So Y equals A. We don't know what A is, so basically all of these is we're trying to find out what A is. So A and X minus 1 plus 6. So this is our H and K from our vertex. And we just plug those in, and now we need to find out what A is. They give us what a Y and an X are for an ordered pair. So let's just plug that in. We get 4 equals A times 2 minus 1 squared plus 6. We'll want to subtract the 6 from both sides, and we'll want to combine that, simplify that a little bit. That gives us negative 2 equals A times 1 squared, right? And that just gives us A is negative 2. Take that and we'll plug that into our equation, and that gives us Y equals negative 2 X minus 1 squared plus 6. Okay. D, same thing. I'll just go over that really quick. Plug in that information. Our vertex is a negative H, and H is a negative 4, so that gives us a positive 4 squared minus 8. And they give us an unordered pair, so we'll plug that in. That gives us negative 5 equals A times negative 2 plus 4 squared minus 8. Okay, and we'll do the same thing we did before. We'll add 8 to both sides. We'll simplify that. It's in the parenthesis, and that will give us 3 equals A times 2 squared. And that's 3 equals A times 4. And then we'll divide both sides. Divide both sides by 4. And we get A equals 3/4. And we will just take that and plug that into our equation. We get Y equals 3/4 X plus 4 squared minus 8. Okay, hopefully that's not too bad. Let's go to the next page. So it says, write yourself a list of steps to describe the process that you did on the previous page. So I'll leave that to you. You may want to write something about look at the equation, or look at the problem, see which form you want to do it or you want to use, and then plug in the given equation whatever you have, plug it into the equation, and including the ordered pair, plug that in, and then solve for A. And then once you have A, you just plug it into your equation with the A included. Okay, so that's pretty much all we do for all these problems that we did and on the homework. And then all we have left is application problems. And we'll be talking more about application problems, I think in our next, in 6.3. Okay, so let's look at this. It says application problems. Remember to start with a drawing, or by drawing a picture. Marking all important points on the graph. Okay, so I'll do my best to do that. Make sure you do that as well when it comes to the homework. There'll be 3 problems that are like this on the homework, and the rest will be like the problems on the first page. Okay, so let's go over that together. Okay, so Sean, or Scene, whatever you'd prefer, is kicking a soccer ball to his dad, who is 10 meters away. So let's start with Sean. Here's Sean. He has his ball, and I'm trying to draw a soccer ball, kind of. Okay. And he kicks it to his dad 10 meters away. Okay. So this is, let's say this is our y-axis, and this is our x-axis, and he kicks it to his dad 10 meters away. And this is dad. Okay? And it says if after 2 meters, so here let's do tick marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It says after 2 meters, so here's 2, the ball is 1 meter in the air. So let's say this is 1 meter right here. Write an equation. That I think it's supposed to be that represents the path of the ball. Okay, so we have our nice equation. We know that we're doing quadratic, so it's going to be something like this to his dad. All right, I mean, maybe not be perfect, but okay. And let's see, given this information, we want to come up with what form we could use. So let's say zeros. Zeros, what are our zeros? 0, 0. And we also have 10, 0. Those are our 2 zeros, or our X intercepts. Okay. Vertex, well, we can come up with the vertex, but I don't know if that would necessarily help us. Okay, because if we already have the X intercepts, and we also have a point, and we have a point of 2, 1, we can kind of look at what we did here for 1A and 1B. Okay, so we can write it in Intercept Form. That will give us y equals, we have A, we don't know what that is yet, but we know what this is like our P and this is our Q, x minus 0 and x minus 10. And we also have a point, so we can plug that in. 1 for our y, 1 equals A, and then x is 2, so we'll do 2, and we'll do 2 minus 10. Okay, so this 2 goes into into that x, into that x. And I just simplified this 0. We don't need to worry about that, okay? So simplify that, so I didn't really leave much room. We end up getting 1 equals a times 2 times -8. That gives us -16. Okay, and then solve for a. We get a equals -1/16. All right. And that makes sense because a is negative, and it's concave down. All we need to do is plug it into our equation. So I'll just plug it in here. Y equals -1/16. And then we have that x times x minus 10. And that would be our equation. Okay? And this is all in this problem. Okay? All right, so let's do the next one. May hits the softball so that its maximum height is 60 feet at 3 seconds. So we're going to have some sort of graph here. This is going to be time, and this is going to be like height. And it says after 3 seconds, 1, 2, 3, the ball is at 60 feet. So we'll just mark a point here. This is 60. So we have the ball is right here. 3 seconds at 60 feet. Okay. It says if she hits the ball 3.5 feet above the ground, because that, well, yeah, it's about height, right? So let's say this is 3.5. This is where the ball is hit. What is the path of the ball in terms of seconds? Okay, so, oh yeah, and this says it's its maximum height. So that tells us something special, okay? Maximum height means that this parabola comes and hits that point like that, meaning that this is our vertex. So our vertex here is 3, 60. And what form are we going to use? We're going to use vertex form. So y equals a times x minus h, which is 3 squared, plus k, which is 60. So that's our equation, and we need to find out what a is. They give us a point, which is one of the points. I should write it here. Point is 0, 3.5. Okay, and so we can plug that in. We get 3.5 equals a times 0 minus 3 squared plus 60. And then you would want to subtract 60 from both sides. Okay, 3.5 minus 60. Sorry, I'm just doing it on my calculator real quick. That gives us negative 56.5 equals a times negative 3 squared is 9. And then we do negative 56.5 divided by 9. And that ends up giving us, so we'll divide both sides by 9. That ends up giving us a equals approximately negative 6.28. And then we'll plug that into our original equation. I need to write this smaller. So that ends up giving us y equals negative 6.28. Oh, that won't work. Hang on, sorry. Need more room. y equals negative 6.28 x minus 3 squared plus 16. So that would be our answer. All right, and then last one says Alex is kicking a field goal. If the ball if the ball landed 22 yards away, what is the equation for the path of the ball in terms of seconds if the maximum height of the ball reaches if if the maximum height the ball reaches is 15 yards. Okay, so let's make our picture. He's kicking the ball at 0, 0, and the ball landed 22, this isn't a very, hang on, this is going to bother me. 22 yards away. So it's going to be some sort of parabola, right, that goes up and then lands at 22 yards, okay? And then it says the maximum height of the ball is 15 yards. 15 yards high, okay, the maximum height. So the maximum height is our vertex. So how do we find what the length of the ball when it was at the vertex? Well, we learned about if we have X intercepts, like these two, the axis of symmetry will be right between those two. So this will be at 11. Okay, so we have our vertex. So here we have two problems that we can solve it using two different, and put it in two different forms. So we have 0, 0 for our zeros, and 0, 22, or opposite, sorry, 22, 0, and we could plug those into our intercept form, or we could use our vertex, which is 11, 15. All right, I'm going to do it in vertex form. You're welcome to do it either way. So y equals a times x minus 11 squared plus 15. And we know one of the points. We actually have 2 points we could put in either way. For our x-intercepts, we could plug in 0 equals a times 0 minus 11 squared. So I'm getting these numbers from here and here. You could also use 22 and 0. And simplify, that ends up, oh, plus 15, I almost forgot that. We want to solve for a, so we're going to subtract 15 from both sides. That cancels. And then we get negative 15 equals a times negative 11 squared is 121. So we'll divide both sides by 121. And we end up getting a equals negative 15 over 121. And then we plug that into our equation. It gives us y equals negative 15 over 121, x minus 11 squared plus 15. All right? And you could do it using zeros as well. All right? So enter the equation you found into your calculator. Look at the graph. Does it model the picture you sketched? Is the maximum value 15 yards? What is the x value, time in seconds, of the maximum? So if you plug that equation into your calculator, you end up finding all of this information as well. Okay? So if you have any questions, let me know. Hopefully this isn't too bad. I mean, it's very similar to what you guys did in Sec 1 using linear equations, except now it's just a quadratic instead, which I feel like isn't a whole lot more difficult than just doing it in linear equations. Okay? All right.